So welcome to third semester mechanical engineering students. In this semester, we are going to introduce you to the subject known as mechanical measurements. In mechanical measurements, you are going to understand the advances in technology, measurement techniques, types of instrumentation devices, innovations, refinements, and also to learn various flow measuring techniques. In this session, we are going to study measurement definition, methods of measurements, significance of measurements, that is why you should do the measurements, then terms applicable to measuring instruments. So to start with, what is measurement? Introduction to measurement is, what is measurement? See, measurement is there everywhere. If you want to know the height of the building, you need to measure it. If you want to know the built-up area of your home, then also you need to measure with the help of measuring tape. If you want to know the distance of your college and home, then also you need to measure it. If you want to know the capacity of the water tank, then also you have to measure it. So without measurement, there is no life at all. So what is measurement? We know that the knowledge of anything is incomplete if it is not expressed with the help of numbers. So every parameter is expressed with the help of numbers. So in measurement, you are expressing the unknown things with some numbers. So there are many ways to define measurement. So we have defined it like this. It is the act of quantitative comparison between the predefined standard and unknown magnitude. Suppose you want to measure this diameter and compare this diameter with the this you can call it as standard. You can call this as standard. You are comparing this diameter which you want to know. This is compared with this standard. This is the measurement standard. So measurement can be defined as a process of comparing with the standards. You are comparing the unknown things with the standards. So what are the requirements of measurements? Measurements has two requirements. One thing is the standard what we use for comparison must be accepted internationally. The standard what we are going to use must be accepted internationally, that is worldwide, and it should be very accurate. Similarly, the apparatus used for comparison must be provable. If the question is asked regarding its accuracy of the instrument, that also should be provable. So these are the requirements of measurements. Then what is the measurement system? The measurement system is basically, in measurement system, we need this input that is shown as measurand. Measurand is nothing but the input. This input is here and it is passed through the sensor cum transducer. So when the input is given to the sensor cum transducer, one type of variable you will be getting, that is called transduced signal. This is again fed to the signal conditioners and we get the driving signal which acts as input to the indicators, recorders, computers, microprocessors or controllers. So in a generalized measuring system, what we have is a measurand at the, to start with. Measurand is nothing but the input. Measurand is nothing but the input. So finally we are getting the output here, that is indicator, recorder, all these things are nothing but the output. So to get this output, we have to send the input through the sensor cum transducer, then it is converted to one type of variable, then it is passed through the signal conditioner for better quality outputs. So this is the generalized measurement system. Then, as we have already seen that measurement is the comparison with the standards. Measurement is comparison with the standards. So what are those standards? Those standards are classified like this: line standard and end standard. In line standard, the length is measured. It is the distance between the centers of engraved lines. Engraved means marked lines. Whereas in end standard, it is the distance between end faces of the standard. For example, for line standard, it is the measuring scale can be thought of as an example. In the scale, you have got so many graduations. So all those graduations are engraved lines. That is the line standard. For end standard, we can think of a block gauge as an example, wherein you are measuring the distance between the end faces. Similarly, you have got other types of standards. They are primary standards, secondary standards, tertiary standards, and working standards. In primary standards, it is also called as the master standard for comparison. These master standards are kept and preserved properly in one location. Master standards are preserved. So these are the nothing but the material standards preserved under the most careful conditions, and it is used only for comparison with the secondary standards. We cannot use these primary standards for day-to-day application. Only for comparison with the secondary standards they are used. So primary standards can be thought of as a master standards. So what are secondary standards? It is also a standard for comparison. It is similar to primary standard, and it is mainly possible and it is distributed to a number of places for safe custody, and it is used for occasional comparison with the tertiary standards. So what is tertiary standard? This is a reference standard. Tertiary standard is nothing but a reference standard. It is used for reference purpose in laboratories and workshops and used for comparison with the working standard. What are working standards? These are used daily in laboratories and workshops. For working standards, very low grade of materials can be used. Question is, why do we need measurement? What is the necessity of doing the measurement? So I said in the beginning itself, if you want to know the height of the building, built up area of your home, you need measurement. So if you don't measure and tell the customers, then it becomes a problem for doing any type of transaction. So various necessities are there for doing the measurements. You have to ensure that the part to be measured, it conforms to the established standards. Then measurement is also done to meet the interchangeability of the manufacturer. Interchangeability means you can have the components assembled to a different component. Then measurement provides the customer satisfaction by ensuring that there are no faulty products reach the customers. So if you do the measurement properly and do the inspection properly, no defective item reaches the customer. Then measurement is also done to coordinate the functions of quality control department, production department, procurement department, and all other departments of the organization. So in every department, measurement is necessary. Quality control, that is the department used for inspection purpose. There you have got all sorts of measuring instruments along with the gauges. Then we can separate the components as acceptable components or rejectable components based on the measurement. Based on measurement, you can classify the components as acceptable component or rejectable component. That is, you can separate the defective parts from the good ones. So measurement has got a lot of importance in mechanical engineering. Now, what are the modes of the measurement? What are the modes of the measurement? Primary measurement, where there is direct observation and comparison. You can see here, you can take any object and compare here and read the results directly. There is no involvement of any conversion. Conversion is one type of variable is converted to other type, that is not there. So directly you are reading the instrument. What are those examples? If you want to measure the length, height, depth or width, such measurements are referred to as direct method of measurement. So what happens in direct measurement is you are getting the results of comparison by simple observation or direct observation. Okay. Then there is another type of measurement that is called as a secondary measurement. It is also called as indirect method. Why it is called indirect? You are not measuring the variable directly. That means you will be converting variable into some other type of variable, and that one you will be measuring. So in secondary measurement, it involves one conversion. Example, pressure or temperature measurement. You see this block diagram, you will understand. there is a system which gives temperature. This is the primary signal to this thermometer. What the thermometer does is it senses the temperature. The duty of the thermometer is to sense the temperature, and after conversion is nothing but the translation. After the translation, there is going to be capillary rise in some instruments, that is length. So you have converted temperature into length here. This is called as a secondary signal, which is recorded as an output, So here you are not reading this length directly. What you are doing is converting this temperature into length. Then you are going to measure it. So this is called as indirect method of measurement. In indirect method of measurement, it involves conversion of one variable into another type of variable that you can see here. Similarly, in indirect method of measurement itself, there is tertiary measurement, where it involves two conversions. Measurement of rotating shaft is an example for this tertiary measurement. There is a rotating shaft which gives the shaft speed as a primary signal to this permanent magnet cup. So here the first conversion takes place. What happens in this first conversion is the speed is converted into eddy current. This is the secondary signal. This current is applied here to aluminum cup and spring pointer, where you have got the second conversion. Here you will get the rotation of the pointer. This is the tertiary signal. Tertiary signal is the signal that is coming after two conversions, and finally that is recorded. Observer's eye means it is the record of the output. So there are different modes of measurement, namely direct method of measurement and indirect method of measurement. Then which one is better and which one is not better, we can think of. So in direct method of measurement, the unknown quantity is measured comparing directly with the primary or secondary standards. The unknown quantity is measured directly with the established standards, that is direct comparison. Indirect comparison, the unknown magnitude is compared with a standard indirectly through the use of calibrated system. Then for direct comparison, human senses are very much necessary for measurement. Here, it consists of a chain of devices which forms the measuring system. In direct comparison, the results obtained are not that dependable. That means they are not accurate. They are not accurate. There is a possibility of some percentage of error in this measurement. Only thing is that the direct comparison is fast. It gives you fast results. Indirect comparison, it is somewhat accurate, as it consists of a detector element, that is a sensor to detect, and it also has got a transducer where it is converted into some sort of variable, and you will get the output. So this is somewhat reliable compared to direct method of measurement. So direct measurement systems use instruments like this. They use instruments like this: linear scales, vernier calipers, micrometers, example for direct methods of measurement. Whereas indirect method of measurements, they uses the instruments like this. There is a indicator or recorder, these things. So in direct method and indirect method, after that, methods of measurement. Methods is with contact and without contact. With contact, the instrument is placed in contact with the object. Example is vernier calipers. Whereas without contact type of measurement, the instrument is not placed in contact with the object. Example is the use of sensors. Absolute or fundamental type of methods of measurement. Here it is based on the measurement of base quantities entering into the measurement system. So this is regarding the methods of measurement. Then we need to understand some measuring instrument qualities, some measuring instrument characteristics. What are those characteristics? We should know our measuring instrument properly. It should give the desired result. It should be reliable. It should give accurate results, all those things. So generally in measurements, what we do is we take series of readings. You're all knowing that. In any experiment, we repeat that experiment for 3 sets of readings or 5 sets of readings. Then we take the average of those readings. That average is shown here as the true value. In measurements, we take average of the readings as a true value. True value means it is near perfect value. How to get this true value in any experimental setup? We have to take at least 3 readings or 5 readings, add those readings and divide that answer by number of observations. Okay, that value is called as the true value. True value, if your measuring instrument is capable of giving the values somewhere close to this true value, then we call that the measuring instrument is accurate. Here you can see in the second diagram. In my second diagram, the measurement readings are clustered near the true value. True value line is this line. This is the true value line. And if your measured value is nothing but the output. If your output is somewhere, anywhere close to this true value, then we say that the instrument is accurate. Do you understand this? The measuring instrument is giving the readings close to this average line. This is the average line called as true value line. So here in this second diagram, it is accurate. Here in my first diagram, the readings are, that is measurement readings are away from the true value. Therefore, we say that this particular instrument is not accurate. But you see one more phenomena here. These measured readings, X is shown as measurement readings. In this diagram, they are clustered around a particular value. They are clustered around a particular value. That is called precision. That is called precision. Here, the readings are not clustered around a particular value. They are scattered. That means this particular instrument is not precise. So these two diagrams are explaining you the difference between precision and accuracy. So you can see here, I repeat this diagram once again. There are two lines here. One is average value line. The other one is true value line here. True value. True value is standard value. Average value is what we get after taking average. So the readings are here. These readings are, they are not near the true value. The readings what I get from my measuring instrument, they are not near to this true value. Therefore, this particular instrument is not accurate, but it is precise because the readings are clustered around a particular value. The instrument is giving the same reading, almost near same reading again and again. That is called precision. Here in the second diagram, here it is a true value and it is the average value. The gap between true value and average value has decreased, and your instrument readings are giving the values somewhere here in this zone. So we can say the gap of average and true value has closed, hence the instrument is accurate. Whereas it is not giving the same reading again and again when the experiment is repeated. Therefore, it is not precise. Okay, so this diagram or this graph tells you the difference between accuracy and precision. Look at this diagram. This diagram is giving you one more explanation. This instrument is both accurate and precise. Here, the instrument readings, they are falling on this line. The average value and true value are almost same. Therefore, this reading, if you can see, it is on that line. Then the experimental readings are clustered around a particular value. Therefore, it is also precise. So precision means it is the repeatability of the measuring instrument, whereas accuracy means the agreement of the readings with the true value. How close you are with the true value is known as accuracy. So these things are important when it comes to the measuring instruments. So we will define it like this. Accuracy, it is the degree to which the measured value agrees with the true value. That is the maximum amount by which the result differs from the true value. Precision represents repeatability or reproducibility of the measurement. If the instrument is not precise, then the great difference in dimensions are measured again and again. Okay. So this is regarding precision. Precision refers to the repeatability and accuracy refers to the difference between true value and measured value. So that is seen here. Here the true value, this is true value, this is average value. The gap is more. Therefore, this instrument is not accurate. Whereas here, the gap is less. True value and measured value, that is average value, gap is less. So it is more accurate. And if your observations or measured readings are same again and again, then it is called precision. In this diagram, you can see both accuracy and precision. Then you also need to understand the terms like readability. Readability indicates, you can see this scale, small scale, this scale. Readability is nothing but the closeness with which the scale of the instrument can be read. How closeness can be read is known as readability. Then there is susceptibility of the device. Susceptibility means the device should have its indications converted into some meaningful number. Then this is most important characteristics for the measuring instrument. Least count. Least count is the least measurable distance. For example, what is the least count of the watch? Our ordinary watch. Minimum time we can measure from our watch is 1 second. So the least count of our watch is 1 second. What is the least count of the ordinary scale? What we are using daily? That is 1 millimeter. We cannot measure a value which is less than 1 millimeter. So least count is nothing but the very least, that means very smallest measurable distance. So it can be defined as the smallest difference between the two indications which can be detected on the instrument scale. Here there are two types of scales. We will notice that the least count can be calculated by an equation which will be discussed later in the chapter. How to find the least count will be discussed later. Similarly, we have got some more interesting characteristics of the measuring instruments, that is range. Range means it is the maximum value of the instrument minus minimum value. That is, it represents highest possible value that can be measured by an instrument. What is the range of your scale? Ordinary scale, what you use daily, that is 15 centimeter. Range is maximum value of the instrument minus minimum value. So if it is a scale, maximum value it can read is 15 centimeter minus 0, that is 15 centimeter. Linearity. If the output here is proportional to the input, input is x-axis, output is y-axis. Output is proportional to the input, then it is called linear. You can see the two graphs here. The straight line, that is this one, it shows ideal straight line. What it means is output is changing corresponding to input. If you change the input, output will also change. That is called as a characteristic linearity. Here it is not happening. Output and input, they are not directly proportional in the second, this curve. So measuring system is said to be linear if the output is linearly proportional to the input. So these are some of the characteristics of the measuring instruments.